Hi, everyone. So it's a huge honor to be here with Pankaj presenting some of the work we've been doing. So why you may be here, you may care. In the last Airflow survey, one of the questions was, which integrations do you use with Airflow? And dbt was in third place, very close to first and second, where 32.5% of the respondents said they used Airflow with dbt, which means if that is representative of the community, 1 every 3 people are using dbt in Airflow. During the last summit, there were several talks about ways of integrating dbt and Airflow, and many of those, we learned a lot from those talks, so we interacted with all these authors, and I tried to capture many of the ideas and be able to bring back to the project we develop. And then during this edition of Airflow Summit, we also had 2 talks preceding ours, one from Lua, who's here, another one from other people who are actually astronomer customers and have been using Cosmos in production. If you didn't have the chance, there will be some of the recordings for those sessions as well. So we hope you're here to see our talk on dbt on Airflow. If you're not, there's still time to escape and get to another session. Some of the topics we're planning to cover here. So a tiny intro of what exactly we're doing, why we have performance issues, what are the performance issues, some metrics, and some of the solutions we came up. So I think the first thing we wanted to highlight is, even though Pankaj and I have been developing Astronomer Cosmos, this is one in many solutions out there to integrate dbt into Airflow. It is not the single solution. It has problems. I don't think there is one that's the ideal solution that solves all the problems. It is one among many. And this diagram quite illustrates this. So we got some of the most popular open source projects that are used to integrate dbt and Airflow. These are statistics from PyP downloads. And you can see that there has been some dispute here on which is the most popular, most downloaded tool over time. Cosmos is this red line. So the adoption has been increased. This other one, very popular, is the dbt cloud provider in Airflow. So you can see there is room for many solutions, and over time this has been changing, which is super exciting. Another very interesting thing, we recently started running a survey, dbt in Airflow, which we'll share the link later on. And one of the questions was, which tool are you using to convert your dbt project into Airflow? And the answers were quite interesting. So we learned that 26% of the respondents don't try to convert dbt into Airflow. And many people, 26%, have their own custom converter from dbt into Airflow. So this means that more than half of the community is not using any of the open source tools we showed before, which shows, well, there is still lots of work we could do to try to unify the solutions. And another interesting thing we found out with the results we got from the dbt and Airflow survey so far is that the second most popular challenge among the respondents, around 150 people replied so far, is the performance. So many people face performance issues while trying to run dbt in Airflow. Just as an interesting thing, the most common challenge people face is to deal with dbt and Airflow projects living in different repos. So we do not believe there is a single solution that will help all the problems in running dbt in Airflow, but we will be discussing what we've done in Cosmos. That's one of the solutions. And hopefully, even if you don't use Cosmos, you will be able to reuse some of the approaches in the problems you may face when you develop in Airflow. So about Cosmos. Cosmos is an open source library, Apache 2. You can install it using pip install Astronomer Cosmos. It is not specific to Astro. So if you're using MWAA, if you're using GCP, if you have your own deployment of Airflow, you can just use and try it. Of course, since we work for Astronomer, if you would like to try Astro, it would be amazing. There is a free trial, but you don't have to. And basically what we do is we try to map the topology of the dbt project into an Airflow DAG, doing the mapping more or less one by one. This means one dbt seed, one dbt source will become an Airflow task. And this helps many people. So let's say you have a DAG original project that has thousands of dbt models. Some of those transformations take longer than others, and you would like to have the flexibility to, via Airflow UI, to be able to retry a task, a single task, if that fails, while keeping the others ones don't having to rerun models and things. So this was one of the motivations. And we try to give us very simple interface to users to do this. So we understand that each company will have a different dbt project with a different topology, and we wanted to have an interface that would be agnostic to how the dbt project looks like. So we expose, there is both the option to use a dbt DAG object or a dbt task group. You would give the path to your dbt project, and Cosmos will do the transformation of that magically, dynamically. Another very used feature in Cosmos is the ability to go from an Airflow connection into a dbt profile file. So in dbt, people usually define a profiles file where you would have all the details of how to connect to the databases where you're trying to run your transformations. On the other hand, in Airflow, we would have connections. So Cosmos allows people to only define things in one place through connections, and then we create the profiles that dbt will be using. So those are some of the main features that we currently have in Cosmos. So among the features we have, so we want to help anyone who has a dbt project to be able to see it granularly when using Airflow. We allow people who want to map Airflow connections to dbt profiles to be able to do this. If you prefer to have your own defined profile, you can still do that. We dynamically create Airflow data sets for every model that you have. So let's say you would like to have data set our schedules. You would be getting this to some extent by free, being able to trigger from specific models of your pipeline new DAGs. People are able to retry only the necessary transformations, which can be very good. It's quite easy to spot if there are failures. We allow people to generate dbt docs and host them within Airflow UI. So this has been a feature introduced in Cosmos 1.4 by a community member, and it's very, very popular. The ability of not having to worry about hosting dbt docs elsewhere and be able to leverage it as a plugin in Airflow. If anyone is interested to see more, please check out our repo in Astronomer Cosmos. One of our goals with Cosmos was to allow users to be in full control of how this conversion from dbt to Airflow goes. So this goes in many levels. So we allow people to give their own profiles file, or we allow to convert from a connection to a profile. From a parsing perspective, many people are happy to represent their dbt projects as manifest files, which are JSONs that represent the topology of the DAG. And that's quite efficient. So we support that, but Cosmos also allows to dynamically run dbt-LS to calculate the topology on the fly during DAG parsing time. And from one hand, this can be super helpful when you're developing locally. But on the other hand, let's say you have a huge dbt project that takes, let's say, 2 minutes to run dbt-LS or more, you may be paying that cost during DAG parsing time. So it is a trade-off, and each person has to evaluate their own needs. Cosmos also implements a custom dbt project parser that was actually the first version of Cosmos before 1.0, where we try to understand the topology given a folder with the dbt project and render that. Although this is quite quick, it's quite error-prone because dbt is evolving, and we're not evolving much that custom parser. So it can be very limited. And then another feature that was recently introduced, very similar to dbt manifest, but the contract is the dbt-LS output file. So you would be running the dbt-LS command in your CI, save the output, and you can use that for Cosmos to render your DAG in Airflow. From a rendering perspective, we allow select, exclude, and selectors, depending on the mode you're using, which means if you have a project with 2,000 nodes, you can select 200 of them, and then nest those groups within task groups in Airflow the way you would like. We allow people to define how they want tests to be represented. Should they be tested together with the model? Would you like to just run tests by the end of your workflow? or you don't care about dbt tests at all. People who are not happy by how Cosmos converts a specific node, let's say a source node, into Airflow, you could redefine that behavior. If you don't like how we are running, for instance, generation source files, and you would like to be using sensors there, you can just say, please, I would like to render source nodes as sensors this way, and you can define those specific behaviors. You can give orgs at a global level and at a command level within dbt. And then, last but not least, Cosmos also allows you to run the dbt command in multiple ways. So let's say you have an environment where you have dbt and Airflow installed in the same place. So assuming you manage to overcome any conflicts between the dependencies. So Cosmos can run that way using dbt as a library. Another option is you don't have dbt available in the same Python virtual env as the Airflow installation, but you have dbt installed somewhere else in the instances where you have the Airflow worker node. So Cosmos can run the dbt binary. Cosmos can create Python virtual envs with dbt to install for you, similar to the data flow operator in Airflow. Cosmos can also run dbt commands from within Docker containers, extending the Docker operator from Airflow. And Cosmos can delegate the dbt execution to happen in Kubernetes, in EKS, and Azure container instances. And there is more. So it's quite extensible. If you have ideas of where the dbt command could be run and we don't support, we welcome contributions there. From an adoption perspective, if we look at last year, this is the number of downloads of Cosmos last year. By April last year, we had daily around 10 downloads. Just last year, we were able to go from 10 daily downloads to somewhere around 2,000 downloads. And the stars grew as well. So we got around 200 stars on the GitHub repo. Right now, we have over 1 million downloads monthly. So daily, we're having around 40,000 downloads. And this is super exciting because if you think about it, last time I checked, Airflow has 20 million downloads per month. dbt itself has 10 million downloads per month. So it means potentially that 1/10 of dbt users are actually trying out Cosmos, if this is representative, which may not be. So we're very excited with the adoption and the feedback the community has been given and the contributions that we are receiving. But as nothing is perfect, although Cosmos has all this tooling and flexibility, it does have problems. So this magic that comes with, given this directory, build the DAG for me, that means we're dynamically rendering the DAG, which means the DAG parsing time will increase. And this can be quite problematic depending on how your Airflow deployment is. Let's say you're not separating the DAG processor process from the main scheduler process. This means that you could be completely messing up your schedule because it may be trying to parse DAGs and then not scheduling things it should. But hopefully you will be having a deployment where these two processes are happening in parallel. So that may not be as problematic. But dynamic DAG rendering can mean larger CPU and memory consumption. It will increase DAG processing time, which may result in times out, may result in scheduling issues. It does lead to longer task queuing times. And this is something I didn't realize until a year ago when I was talking to Jarek and other people who know more about Airflow than I. And then another thing to keep in mind is this idea of running one model per task is slower than if you were running a single dbt command with all the pipeline, because there is an overhead. There will be an overhead to schedule a task. There will be some communication. And so this may not be the solution for many people. And then another customer was very frustrated. He said, look at my computer. I run this dbt CLI in 10 seconds. And then I try to use Cosmos. It's taking 1 minute. How come? And I said, but come on, you're comparing a distributed orchestration tool with a single command in a MacBook Pro. It doesn't feel very fair. So it's important to set expectations there. So, and one key thing that this I learned, and I would love if people who don't know learn a bit as well. Before, I thought, okay, it's problematic to have a DAG that is built dynamically takes some time because it would affect the scheduler. But I thought this just happens at the scheduler side of the DAG processor. So that's not so bad because it may affect the scheduler. We isolate the DAG processor, and that's okay. DAGs may take longer to refresh from a version perspective, but it won't be too bad if that takes a bit longer, a few seconds. But what I didn't realize is that while the DAG processor consumes the DAGs from the DAG bag and serializes the DAGs and stores in the metadata database, that representation serialized in the metadata is not used by the worker nodes to understand what the DAG is. So currently, as Airflow 2.10, every time a worker is going to run a task, it actually has to reparse the DAG. So it has to fetch the DAG from the DAG bag and rebuild that. So this means that if a DAG is slow from a DAG run perspective, we're paying the cost to parse that DAG from the moment it will be parsed and scheduled to the moment each task run is being run in a worker node. So if your DAG parsing takes 5 seconds, you will be paying this cost times the amount of task runs you have. And then it will depend on concurrency and everything, so it's not necessarily linear, but it can be quite a lot. So if you had to take one lesson from here and you don't care about Cosmos and other things, I think this is a quite cool thing to remember, that the DAGs are currently parsed in these 2 places. And this means that we have at least 1 plus n times in the task life cycle that this will happen. And then we look at what Cosmos is trying to do during parsing time. So Cosmos may want to create a profiles YAML if people are not giving it, if you're using profile mapping. Second, Cosmos may be trying to run dbt-Deps depending on your configuration, because people can define packages YAML, which may not be installed in the Airflow worker node, and then you want to run some commands there, and if you don't run dbt-Deps, it will just fail. So people can opt out, but that may happen. Then Cosmos does need to understand the dbt project topology somehow. This may be from a manifest file or somewhere else, but it has to do that. Then depends on options to selecting models. If you're using a manifest and you want to use as a selector, Cosmos has a custom logic to select and exclude nodes that will be executed. And then finally, we assemble the Airflow DAG. So imagine all of these steps happening during DAG parsing, and this will be proportional to the dbt project file. So we've seen people successfully using 500 models to 2,000 models, but it will really depend. So it feels a bit too much to be running this in 1 plus n time. Another thing to keep in mind is the flow in Cosmos when we run tasks. So every time a task is run, again, we may be creating the profiles YAML, then we may create a Python virtual env if people opted by the execution mode virtual env. We may have to run that because there is no guarantee the worker node has the dependencies installed or the Kubernetes pod. Then we would be running the desired dbt command. And then in many of Cosmos operators, people can define callbacks. So this is all that happens during a task run. So the first aspect we have to say is, the more magic you use in Cosmos, the more expense you will likely have. Someone pays the cost of that magic. So there are ways where Cosmos will be more performatic than others, and so it is always a matter of choice. But through the last months, I would say last 8 months, several people have been working to improve the performance, even though Cosmos does all those things. And we've seen significant improvements, and Pankaj and I will be walking through some of these improvements. From a timeline perspective, Cosmos was born in December 2022 as a hackaday project in Astronomer, where people were just tired of many customers having their custom DAG builders out of dbt. And the CRE team thought, we should just try to propose some tools so people can reuse And that will make our lives easier to support them than each one trying to do this in a different way. Since then, there were many iterations before a stable release that happened July last year. And then in Airflow Summit, it became clear that performance was an issue. And then we made sure this last releases, the focus was pretty much strategies to improve the performance so people could have a better experience. There are some other features that were implemented in this way, in this path, in this journey. And it's quite exciting that, for instance, the contributor of source nodes, how Cosmos renders source nodes is here, Alejandro, and it was his first open source contribution. And we had many, many contributors doing this journey, like supporting model versioning in dbt and make sure those rendered properly in Cosmos, YAML selector support, the dbt docs. So those features were done by, could have been done by any of you. Okay, so performance hurdles. So throughout this, we had lots of feedback from users. So a very common issue that we received both in Slack within and outside of Astronomer was, my task is being killed when I'm using Cosmos. Why is that happening? And then we would usually try to say, okay, so you have a few issues. Have you tried to use the manifest file? And then people would say, I don't want to have to build the manifest file. And then we would say, why don't you use a select? Just get a subset of the nodes. People would say, I don't want that. And then we said, okay, so your option is just to increase the timeout. Accept to increase your DAG timeout to import things, and that will improve. And then many people did that, which may have delayed scheduling, but others said, I don't like this solution. That's bad. And then we said, okay, we would do our best to get dbt-LS working better. There were feedback on the community again on slowness, so you can see this January, February 2014, April, people saying before it was taking 15 minutes, now it's taking 30 minutes. And then there was this very demanding customer from Astronomer who said, I implemented the same pipeline using bash operators. And with Cosmos, I'm facing 20 to 30 seconds in the task queuing time. But with my bash operator, it is almost 0. So what are you guys doing wrong? And then we worked closely with them to try to overcome those things. Pankaj, it's yours.
Thank you.
You will see.
Yeah, thank you for building the story, Tatiana. Great story. Yeah, before we move on to how our contributors help improve the performance of Cosmos, we'd like to share how we measured the performance improvements over Cosmos versions. So next slide, please, Tatiana. So like Tatiana mentioned earlier, for the diagram, there are various parameters that could take time. There's DAG passing time, there's task run time. For DAG passing, there are these things happening. We create profile, dbt deps is run, and then we pass the dbt project to convert it into Airflow DAG. And then you could select some dbt nodes optionally, and then also build the DAG or task group finally. And similarly, in the task runtime, the main thing that happens is it actually runs the dbt command, and these are the optional steps that happen. One of the improvements we saw is once your DAG is created, you give a DAG run. The tasks were running, but the queue time was more than what was expected. And this is where the DAG was getting passed every time on the worker node. What DAG runtime comprises is all of this together, and the end objective was to optimize this DAG runtime. So to measure the performance across versions, what we did is we had an identical infrastructure setup across multiple versions of Cosmos. So with this, we initiated multiple deployments on Astro. We used 2.93 Airflow, and then Celery Executor, the minimum worker type that we have available on Astro. Concurrency is set to 1 because we wanted to check at any given point of time on a worker, only one task is run, and that is consistent across Cosmos versions. We set the min and max workers to 4, so that means we have 4 G-Unicorn processes running all the time. That means we'll have 4 tasks running at the same time at any given point of time. This is high availability scheduler, and then Astro recently launched this separate DAG processor. So previously it was to run inside the scheduler. Now you can also have a separate DAG processor running, have its resources. This was the setup we did. We used the classic old Jaffel-Shaw project for benchmarking the project across Cosmos versions. So this is the baseline. This is from where the contributors try to increase the Cosmos performance. So based on the 4 parameters we saw earlier, these are the times. The DAG passing for the dbt Jaffel-Shaw project took 8 seconds. task runtime 9 seconds, task queue time 9 seconds again. So this is what over here, like again, the DAG is passed. So it gets the latest changes in the dbt project. And the runtime, overall runtime was like this dbt-Airflow shop ran for about 1 minute, 29 seconds. So across all the versions you would see, this is the node mode that we use, dbt-ls, and the profile mapping. So one outlier would be 1.3, where we introduce a new passing method, which is the dbt-ls file we'll cover later on. So we are going to now cover like how we overcame performance hurdles. I'm one of the latest contributors to Cosmos, so I didn't contribute a lot to overcoming these hurdles probably in the coming future, but we have something to show to you. This is a small teaser video of what we are going to cover next. So over here we are going to show like using the same DAG on different Cosmos versions. So one is Cosmos 1.2 and Cosmos 1.6. It's the same DAG. On the left you would see Cosmos 1.2. Over here is Cosmos 1.6. Same DAG, and yes, we could start now. They have the same schedule, and if you look at the time at the top, so it would be triggered now at like 2:30 p.m. So the time is already passed, so the DAG would be scheduled now, and you'll see like on both the ends, like we are going to show the graph view. This is how you'll see the success of the task, like progress of the task. Like over here, it's already progressing, like so many tasks are already running, and some of them are completed. Over there, it's still in queuing state. So this is what we are going to cover soon. Like it remains in queued state for a long time. And you see here, over here, like this DAG is about to finish, like, and this is still processing the earlier nodes. Like, so that's what we are going to see, like how we optimize this. Yeah, thank you for the early approach. Yeah. And you see, like it's done in like less than a minute. Over there, it's still running. Oh my God, yeah, it's taking a long time. Still, and it's stealing our time from the top, but yeah, almost about to complete, hopefully. Hopefully.
Yes, and this will
Hopefully.
speed up by 2 times, by the way. So it would take quite
It's
long.
done now. So you see, like it's taking 1 minute 53 seconds. This is taking 59 seconds. And if you look at the Gantt chart, so this is the queue time delay, and over here like 0. Thanks to Tatiana for this amazing contribution to queue time for 0. So that was I had. Yeah, that was I had to share. Moving on, I think.
Okay, so for us to accomplish this, so it is a journey, and I don't think we will be able to get into detail in all those versions, but the slides will be available later. And then you can check, we're linking the PRs and everything. That thing of the task queue became a personal challenge because I was very offended to be compared with the best operator and said, no, we need to do something. It is not possible. So throughout the versions of Cosmos, so the baseline that Pankaj showed, then a contribution from the community on similar to using a manifest file, but to use the dbt-ls output. In Cosmos 1.4, we had a script to improve checking the performance, so we could programmatically know more or less if we're improving or getting worse. Justin Bandoro introduced the dbt runner, which allows if dbt and Airflow are in the same virtual env, choose dbt as a library, as opposed to having to create a sub-process for each dbt command that's triggered from a Airflow worker node. We started leveraging dbt partial parse file, which is a sort of cache of the dbt topology, and that it's cheaper to use this than to have to parse a manifest file if you're using a dbt command to run something. And we also started running dbt-deps only if people actually had a package YAML. Before, we would always run dbt-deps if people were using that. So imagine creating a sub-process, trying to run that thing. Not good. So those were 1.4 changes. In 1.5, that's where we overcame the task queuing time. We actually started caching the dbt-ls output in Airflow variables, which can be quite polemic. So the first attempt was, what if when we generate this Airflow DAG, we pickle it and we save it into the Airflow worker node or scheduler, and then we just try to use that pickle. So we thought, what's the quickest, dirtiest thing to avoid this parsing time during real time? And then that worked very well locally. But when we deployed into distributed Airflow, what happened was worker nodes live and die. And if you have 10 worker nodes, you had to create that cache per worker node. And then there are all concerns with pickle. So I said, okay, what if we try to store that in a remote storage or dbt-ls? And then we saw, well, GS variables could be quite cool because people can actually see their cache and they could purge it if they want to. And then there were lots of interesting things with this, and this helped with the queuing time. I will show that more further. We started caching the profile mapping locally, and then we started caching package lock that helps with the speed of dbt-Deps. We started persisting dbt virtual env directory if people wanted Cosmos to manage the dbt if they want to. Otherwise, it would just create a temporary one and delete. So you pay the cost for what you want. And then in 1.6, Pankaj Koti implemented this same caching strategy for dbt-LS, but then using a remote storage, which is quite niche. So you're not messing up with your Airflow metadata database, and you can still benefit from this performance improvement. So this contribution was quite straightforward. The idea is in your CI/CD, you would run dbt-LS output, save this JSON, and you give to Cosmos this JSON with the topology. And then this saves Cosmos a lot of time because Cosmos doesn't have to parse the project or select nodes. By doing this, you gain massive performance improvements. But then you're not using the dynamic side of Cosmos, which is something many customers said, we want that. We don't want to have this. So some improvements. This dbt-Deps that we were not running if the file package YAML wasn't there. Another one that Daniel Reeves and myself worked on was to leverage the partial parse file. This improved sometimes in 34%, depending on the DAG, sometimes by 22%. So we had massive improvements, and we would cache this as well in the Airflow worker node. And then we try to illustrate here where the improvement is happening, if it is in DAG parsing or task run. And by task run, we're excluding the queuing time, because you know about that already. So just the execution of the task itself after it has been queued, so after the DAG has been processed. So we're trying to showcase where each PR affected. Then Justin Bandoru introduced the dbt runner, if you have things in the same virtual env. This not only made things much faster, for some DAGs it improves by 3 times the speed to run dbt commands, but this also helped saving a lot of CPU because we were not having to create a sub-process to execute the dbt command, we're just using dbt as a library. Again, this is not for everyone because many people face lots of conflicts when having Airflow and dbt, but if you're not one of those, you can leverage this. So we try to compare this performance. Since it's not fair, many people want to choose dbt-LS. So the improvement we had in 1.3 is incompatible with this. So from 1.4 onwards, we're comparing improvements that affect dbt-LS in real time, the dynamic one. So you can see the improvements are not as impressive as 1.3, but it's still they are going in a good direction. If you think that there is an improvement of 50% there, or 1/3 got smaller, it's quite good. Cosmos 1.5, it was the first contribution from Pankaj Sync. We managed to get the cache of profile mapping, which avoids us to have to regenerate that all the time, which saved by 11%, depending on the size of the DAG, on the profile and everything. And that affects both DAG parsing and also task run. This change I did that helped with task queuing time, that first I attempted to do the local pickle, and then I exercised using the variables. It was really fun because we wanted to make sure this cache would be automatically purged if the dbt project changed. We wanted to make sure this cache would be automatically purged if variables that are used by the dbt pipeline were changed. They didn't want, if there were changes to other parts of the DAG, for this to be purged. So we had many edge cases and interesting things. And then they wanted the cache to be deleted if they removed the DAG or renamed the DAG. So there were 84 commits in this PR. We had 10 alpha releases out of this before it became something. It was born. But it was very exciting to see the improvements. In some DAGs, it was 50%. And while we were developing, a community member was very excited, gave some thumbs up. And I said, could you please give a try? He said, I already tried. And then he said, it reduced from running simple DAGs from 13 minutes to 2 minutes. So, and our tests speed up. So we were, oh, that's good. We're finally going in a good direction. So the profiles change we mentioned. So you can see the improvement between 1.5 and 1.5 is quite significant. and very comparable to the dbt-LS output approach. Pankaj.
We are at Cosmos 1.6, just released a couple of weeks back. So this is the first contribution we'd like to mention. Again, contributor Pankaj Singh. Pankaj Singh is here, by the way. So we are caching the package log.yaml. So this is effective when you run dbt-deps. So this helps DAG passing, as well as this is similar to caching the profiles.yaml and like the partial pass message pack that we saw in the previous versions. This helps in DAG passing. So this is an overall summary during the journey, like how the performance has increased. 1.5, yeah. So this is comparing all dbt-LS and then profile mapping. So the next is caching the dbt-LS output using remote store. So in 1.5, we did introduce this caching via variables, Airflow metadata variables. So every time your DAG is getting passed, so it will cache in the variables. That's an awesome solution, but sometimes you might not want to store it into Airflow metadatabase. So we are giving an alternative. This is not actually optimizing your speed, but it's optimizing your disk usage. It's saving you from exploring your metadata base. So with that, what you can do is you can store your dbt-LS output into remote stores. That's about it. The next one, Tatiana, please.
Okay, one comment about this one is that to store in the Airflow metadata database, we of course compress the output of dbt-LS. And we did some tests with DAGs that were 5,000 dbt nodes to make sure the space we were using wouldn't crash and would be compatible. So just a disclaimer. But the customer that we were working with, that is actually a gaming company, they said, we really want to be able to cache this elsewhere. But then we released alphas of this and they never gave any feedback. So they remain using the variable as far as we know. Another improvement that came with Lemma was the possibility of remain with the virtual env that Cosmos creates. So people just reusing the same directory across task runs, so you don't have to create one. This affects task run. So overall, these are the numbers. These were some of the improvements. So along the last 8 months, we had many improvements. We reduced by at least 25% the regional DAG runtime. And we had actually more than 8 developers who contributed to this work. For future, if anyone here would like to contribute, there are many things we can improve. These are some of them. The one I feel more passionate about is stop using dbt to run the actual tasks. So to precompile the SQL using dbt, and then we use Airflow native operators to run if you're running against Snowflake, if you're running against BigQuery, and then we can leverage Airflow deferrable operators, and it will save tons of money in your Airflow deployment, which may not be very good from a business perspective, from a strong phrases, but I think it's amazing from a user perspective, and then it may encourage even further the adoption of this sort of tooling. There are more ideas. If you are interested in contributing, we would love additional hands. If you had to have 4 takeaways from the session, Cosmos 1.6 is faster. You saw the video, so trust us. Understanding how Airflow works is critical. So we really want to improve how Airflow supports dynamic DAG generation to make sure this work is easier. Ideally, this caching and reusability would be built in Airflow, not in the tool using it. It's very important to have a systematic way of measuring so we can see the progress from a number perspective. And this was only possible with the community. So this is actually outdated. We have 101 contributors and growing. These are the current maintainers. And we're really proud that 1/3 of the current maintainers of the project are not from Astronomer. And we're willing to promote more people from the community to becoming maintainers if you contribute over time. So thank you very much.